Next I'll work 24b, whose instructions are also use the elimination method to find the solution to the following system of equations. Remember, elimination method means you want to find either your x's or your y's to have the same coefficient with a different sign so that they cancel each other out when you add the two equations. Well, again, here they're both positive. 9 is not a multiple of 6, so I'm going to have to multiply by both, and one of them by a negative if I choose my x's. Here they're both negative. 6 is not a multiple of 4, so I can't multiply just one equation. I'll have to multiply both, and I'll have to multiply by one of them by a negative so that I have opposite signs. So really it's sort of 6 of one, half dozen of the other, which one I choose here. There's no benefit to choosing one over the other. So this time I'll choose to make my x's have the same number but opposite signs. So if I multiply 6 by 3, I get 18, and if I multiply 9 by 2, I get 18. So that's what I'm going to choose to do. I'm going to multiply the top equation by 3, but now remember I said one of them I had to multiply by a negative, so I'm going to multiply the bottom equation by negative 2, because that's going to give me a positive 18 and a negative 18, which of course is what I need. So I'm going to move those equations over here. 3 times 6 is 18x, minus 3 times 4 is 12y. Don't forget you have to multiply by all three terms. And 3 times 14 is 42. Multiplied everything by that 3. And I'm going to do the same thing down here now, but with negative 2. Negative 2 times 9 is negative 18x. Negative 2 times negative 6 is positive 12y. And negative 2 times 21 is negative 42. So now that I have a positive and a negative 18 here, I can add my two equations and cancel out that. That gives me 0. Those also cancel out, and those also cancel out. So I end up with 0 equals 0. Now remember, when you're solving equations that are linear and you have two of them, three things can happen. The two lines, and I'll just sort of give you an example here. I have one line like this and the other line like this, and the two lines cross each other here. They have one solution. And remember, these are equations of lines in standard form. The other thing, next thing I should say that can happen, is I have two lines and they're parallel to each other and they never cross. Or, as a last example, I can have a line, and then when I go to graph the second line, it ends up being exactly the same line. How many solutions would that have? Infinitely many. Matter of fact, all real numbers would work to make both of those equations true. So that's infinitely many solutions, or all real numbers. And that happens when you multiply your equations by something, they end up being identical equations. If I multiplied this one through by -1, I would have that one. They're actually identical equations. Or when I eliminate my variable, the left-hand number is exactly the same as the right-hand number. So the solution to this is all real. Whoops. Didn't write that very well, did I? All real numbers. Okay, that's the solution to that equation, all real numbers. Now, if when I did this, I eliminated both my variables, but I got 0 equals 7 or 14 equals 2, two numbers that did not equal, that would mean those lines had been parallel and there was no solution to that. This example gives you one solution. This example gives you none. It happens when you solve your equation and the numbers are not equal to each other. This example gives you all real numbers, which happens when you solve your equation. Both your variables are eliminated and your numbers do equal each other. There you go.